So we are now on to 4.2, which is all about irrational numbers. Okay, so we have to be able to describe what a rational number is first of all. So here we can kind of see a list of rational numbers here. Okay, and later we'll put more of a actual definition to it, but for right now let's just see kind of what the pattern is for rational numbers here. So for 0.8, well, that is a really simple number. 0.8, this is a, it's called a terminating number or decimal. Okay, so it doesn't continue on and on and on and on. So this thing just terminates. 0.8, as simple as that. 0.8, you can also represent this as a fraction. It is 4/5. So if we pull out a calculator here, oh, it's not quite what I want. I want this guy here. If we pull out a calculator here, 4/5 is 4 dividing 5, and we can see that's 0.8. So we can represent this using fractions. Now, what does this bar mean? Okay, we read this as 0.5 repeating. So we could also write this as 0.45454545 forever and ever and ever and ever. That's why you put that bar on the top, 0.5 bar. Now here, this also can be represented as a fraction. It is 45/99. That equals, we can see in our calculator, and of course our calculator is going to end at some point, but recognize this is just going to keep repeating on and on and on and on and on forever and ever and ever and ever and ever. Okay, so this also can be represented as a nice fraction. Okay, what about negative 1.45? So even though it's a negative, it still can be a rational number. Okay, here, negative 1.45, well, let's talk about that. We can actually represent this as a fraction. If I put negative 1.45, I can press math and put fraction, and my calculator shows me that negative 29/20, if I enter negative, or if I do negative 29 dividing 20, that gives me negative 1.45. So we can also represent this using a fraction. Okay, and recognize it's a decimal number, but again, it terminates. Okay, it doesn't go on and on and on forever, and it doesn't repeat. So if it does go on and on forever, it has to repeat itself in order to be a rational number. 2 is a pretty easy rational number, right? We could even technically represent 2 as 2/1, right? If you really wanted to show that it could be a fraction. Root of 100, well, that's a perfect root. Root of 100 equals 10. So that's a perfect square, okay? And my answer is 10. How about here? Root 145, or root 144 over root 25. Recognize, we'll learn about this a little later, but you can actually, and this is a rule, square root each individual thing. So the square root of 144 gives me 12, and the square root of 25 gives me 5. So here we can see that gives me a fractional number, but we can also plug 12 divided by 5, and that also just gives me 2.4. So a decimal with a terminating decimal. Okay, and then 3/4, of course, that is a rational number. That will give us 0.75. If we plug that in, 3 divided by 4 gives us 0.75. So hopefully you can see what the relationship for rational numbers is. If we come here, we can see a definition. So the definition of a rational number can be made by dividing two integers. So remember what an integer is. So that's kind of listed below here. It's -2, -1, 0, 1, 2. It's any number that's not a decimal. Okay, so if we can make a fraction where the numerator and the denominator are indeed integers, then that therefore is a rational number. So we can see we can represent every single number here in terms of a fraction where we're dividing two integer numbers. Okay, now into irrational numbers. So irrational numbers are numbers that have no sense in them. think about what irrational means. To be irrational means to not make sense. That's what the word irrational means. If someone's being irrational, it means they're not making sense. So if we plug in square root 3 into my calculator over here, so our I should be over here, we can notice that this gives me a decimal number that just goes on and on and on forever. Recognize that even though your calculator terminates, there's no pattern happening here. Nothing's repeating itself or anything like that. And this will continue on and on and on forever. Okay, we can see down here, we have and whenever you put ... this means it just keeps going. Okay, so this has no pattern at all. It's just random numbers. So this is an irrational number. If we come here, negative cube of 10, well, let's put in negative, and then math 4, which will give us the cube root 10, and we'll go over how to get that exactly in our calculator in a later section. But just recognize that this, if we plug in our calculator, it equals negative 2.1544, and there's no pattern going on here. So this goes on and on forever. So hopefully we can see how all of these things, I guess I accidentally wrote square root 3 2 times, but you can see all of these numbers just have no sense to them once the decimal place happens. Okay, and that makes them irrational. Here we can see that we could break this apart to square root 20 over square root 64. Square root 64 here is actually a perfect square. If we plug that in our calculator, you'll get 8. But square root 20 is not. So if I do square root 20, well, that gives me 4.4721 and no sense to it at all. So since this top number is not an integer, well, this is not rational. So this is irrational. It's kind of like pi. Pi is irrational because pi equals 3.14. Let's see what our calculator goes to. 141592654, and this is going to continue on and on and on and on forever. So if you're really interested, you could look up and see what person has memorized the most amount of numbers in pi. It's a ridiculous amount. That's all I can say. So for an irrational number, what is the definition? So the definition of a rational number, an irrational number cannot be made by dividing two integers. Okay, so these values here, there's no way to represent an integer dividing an integer to represent these. So that's one way. Another way is to see a number that is a non-repeating, never-ending decimal number. So remember, nothing's repeating here, nothing's terminating here. It just goes on and on and on forever without any sense to it. So that makes it irrational. Another way to tell if it's irrational is if you have a cube or a square root, if you can't perfectly root that thing, that is also a rational number, and that's mainly what we're talking about today. Okay, so here we can see kind of a definition of all real numbers. So real numbers include every single number that can exist on a number line. So that'll include 0, that includes 0.00001, that includes 1, that includes negative 1.3, so on and so forth. So any number you can put on a number line. And this is kind of how it's broken up. Whole numbers are positive numbers with 0 included. Integers are negative numbers that are whole numbers. So integers include -3, -2. They also include 0 and 4/3. So that's why integers includes the whole numbers here. Irrational numbers are the numbers that can be represented, again, using fractions. Another way to think about it is rational numbers are decimals that terminate. So 0.375, that's an easy thing to understand. And again, if we plug that into our calculator, 1.375, and if we press math fraction, it'll show us that that equals 11/8. So we can also represent it using a fraction. It's also something that's repeating, okay? Any repeating value, you can actually just put that 56/99, and that's going to give you 0.56, 0.56. Now, this is something good to point out. See how there's a 7 there? That's your calculator not being as smart as you, okay? So your calculator wants to round and kind of give you just an easy thing to work with, but that's not what this number is. It's going to repeat for infinity. So what it'll do is it'll round that 6 up to a 7 and just stop. But that is not what you want to see. So this thing will still continue on. Your calculator is just trying to make it easy for you, but it honestly makes it a little bit more confusing. So this will still repeat 5.56, 56, 56 forever and ever and ever. And then it's those irrational numbers over here, and we can see that they've represented every single irrational number as either a root or just pi. That's because, again, if you're rooting something and it's not a perfect square, okay, it will be irrational. So any number, so if I do square root, so if I go square root 8, that's an irrational number because nothing perfectly squares. Remember, 2 squared is 4, and then 3 squared is 9, right? So the square root of 9 is 3, the square root of 4 is 2, but that falls between square root 8. So it's roughly that, which is an irrational number, okay? So let's go to example 1 here and kind of go through a few examples. So determine which numbers are rational or irrational. Explain your reasoning. Well, here, recognize that 8 over negative 9 can also be represented as negative 8 over 9, which can also be represented as negative 8 over 9. Okay, they're all the exact same thing. This negative value can kind of float and go to wherever it wants. Now, first of all, this is going to be a rational number because I have 2 integers, 8 and 9, dividing each other. Okay, so that's one way to tell. So my 2 numbers that are integers are dividing. It's also an integer because if I plug this into my calculator, I'm going to get 0.8 repeating. So negative 8 divided by 9, okay, that's going to give me, and again, your calculator tries to round it. It's not going to actually happen. This is just going to be 0.888888888 forever and ever and ever. And we can simply represent that with a bar. So negative 0.8 bar. And remember, since it's repeating and it has a pattern, this is also a way to tell that it is rational. Okay? So this thing is rational. Let's go over here. So the cube root of negative 64 over 8. So remember, we have that rule where if you have a fraction, let's say m over a here, and remember this is the index, so that's 4.1, this will be n root m divided n root a. So I'm going to do that here, where m is 64, well negative 64, and then a is 8. So I can represent this as the cube root of negative 64 over the cube root of 8. Here, we can use our calculator, okay, if we want, but you should know at this point that, let's see, 4 cubed, where's my cube button? I don't have a cube button. So 4 cubed equals 64. That means negative 4 cubed equals negative 64, okay? So the cube root, so I can kind of understand this as well, as negative 4 equals the cube root of negative 64. So remember from our 4.1, if your index is odd, you can have negative values as your radicand, okay? So the cube root of negative 64 is going to be negative 4. So this equals an integer. And what would be the cube root of 8? Well, I know that 2 cubed equals 8. So that makes 2 equal the cube root of 8. So here, the cube root of 8 equals 2. So this will be 2. And if you check this out, negative 4 is an integer, and 2 is an integer. So you have two integers dividing each other, making this thing rational. Okay, so this is a rational number. Okay, and for some reason that deleted, so we're going to do that. And you could even further simplify this. -4 divided by 2 we know is -2, which of course is a rational number. You could have also plugged this in your calculator, going math, cube root, and we could have plugged in -64 dividing 8. And that's going to give us -2. So you can see that there. So it's a rational number because we can actually break these down. Both these things are perfect cubes. Now let's see root 48. So root 48, well, let's think about, remember, if there's nothing there, it's a square. So 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49. So here, remember, we can use this and write it a little differently. We can write it as 1 equals square root 1, 2 equals square root 4, 3 equals square root 9, 4 equals square root 16, 5 equals square root 25, 6 equals square root 36, and 7 equals square root 49. So these are perfect squares. You can notice that we skip 48 here. So this guy, the square root of 48, this falls between, so BT means between root 36 and square root 49. So that means this thing is not a perfect square. So if you're not a perfect square or a perfect cube, depending on your index, that makes you an irrational number. And you can check with your calculator. Let's see what happens when we square root 48 in our calculator. Recognize you get a number that goes on and on with no pattern. 92820323, there's no pattern going on there. Nothing's repeating itself or anything like that. So there's two ways to tell. A, we told that it skips over in the perfect square sequence, so it's not a perfect square. Therefore, this is not, well, therefore it's irrational. As well as when we plug this into our calculator, we are able to see that indeed there is no pattern occurring. So that would be 320,323. So this has no pattern. It's irrational. It makes no sense. It makes the whole number irrational. So this guy is an irrational number. Okay, so hopefully you're seeing how irrational and irrational numbers work. Okay. Now let's I've been kind of just doing cube rooting and square rooting in my calculator. It is a useful thing to know how to do. So that's what we're gonna quickly go over here. How do I use my calculator to square root, cube root, or fourth root, or just kind of any type of rooting? So let's focus on square rooting. You already know how to square root, hopefully. You've used it quite a few times. The first thing you will press is the second button, which is right here. And then you will press the x squared because now you are essentially getting that little square root value there. And then you are going to put 4 inside. Okay, so that equals 2. How do I square root 16? It's the same thing. Second, and then you get now the yellow values, square root 16. So that's going to give me 4. Let's do this last one, the square root of 8. So second x squared, 8. And again, that is an irrational number. So we can see this goes on and on and on. This guy is irrational. Okay, it's a little bit different on how to cube root. If we look at how to cube root, we can see the steps here. The same. What you're going to do is you're going to press math. So math is this button right here. And it's going to give you a list. It's going to look a little different on your calculator, of course, but I'm pretty sure the same things are happening. It says fraction, decimal, 3, you want to find the value that says where the index is 3. So I think it is 4 on your calculator. So you'll want to press this, number 4, to engage it. And now you should get an index of 3 on your radical. And now we can plug in 27. So that'll give us 3. Remember, if you have odd indexes, you can have negative values inside. So here, again, I want to press math, go down to 4, and negative 64. So that will give me negative 4. Let's see here. So math 4, 300. So 6.694 ... Remember, there's no pattern going on here, so this thing is irrational. Okay, how could I fourth root? So fourth rooting is a little different. Anytime it's not just square rooting or cube rooting, you first have to plug in your index. So here you're gonna enter 4 because you're entering your index in. So I'm just gonna press 4 on my calculator. Then you're gonna press math, so math again. And now you're gonna scroll down to the 5th option. Because the 5th option, essentially it should say a little x and then a radical symbol. That's because your x value is becoming the number beside it on your, so here my index has now, my 4 has now popped up into my index, and you're going to press enter on that. We already did that. And now you're going to type the number inside your root. So in this case, it would be 8. So that is not a perfect fourth root, so it looks like it's an irrational number. Okay, let's see this guy here. So again, I'm going to press 4, math, and then I'm going to go down towards x radical, and now my index is that number 2401. And it looks like that's actually a perfect, so this thing is a perfect fourth root, making it rational. Okay, this guy above would be irrational. Okay, let's go here. So again, for math, 300, and that's another irrational number. Okay, so this is irrational. And I should mention it's the whole number, of course. This whole thing is irrational because it's a decimal number that doesn't have any sense to it, no pattern, and it never ends. Okay, now how about just end rooting? What I mean by end rooting is where the index number is just a bunch of different things. You don't fully need, like, you will maybe run into a question or two about this. This is kind of at the harder end. It's sort of the same thing as fourth rooting, except your index is changing. So in this case, since my index is 6, I'm going to first press 6 on my calculator. Then I'm going to do the same thing, math, and I'm going to choose the 5th option because that takes the number you just entered and puts it as its index. So this is going to be a pretty small number of 1.414213562. And it's going to go on and on forever and ever and ever. How about this next one? So I'm going to press 5, my index, math, and I'm going to choose x root 5, 2401, and that gives me another irrational number. Okay, and that's going to go on and on and on forever. Here, check it out. So first of all, I have an even index. Remember, if you have an even index, you can't have negative. So I already know that this is going to pop up as an error, so I would write it does not exist, so D and E. But we can see here anyway. So I'm going to press 8, math, and I'm going to choose the 5th option to make my number I just put as my index. Plug that in, and you're not going to get a real answer. You're going to get an error in your calculator. Okay, and again, if that was an odd number, we would be able to find a solution there. Okay, so hopefully that made sense on how to use a calculator. I'm going to warn you guys, you might be having a test where you won't be using a calculator, okay? So we have to learn some methods on how to do this type of stuff, not using calculators, okay? So please email me or give me a quick email or contact me just to make sure if you do have that quiz or not, where there is the portion without a calculator, okay? So let's do some more questions. and then you can go on and try some stuff out on your own. So order the following numbers from least to greatest and use your calculator. Okay, so how can this one shouldn't be too hard because I'm not using my calculator. So here, the square root of 18, let's pull out our calculator and figure out what the square root of 18 is. So again, square rooting is pretty easy. You're just going to press second square root 18. So this equals 4.24, and I'm going to round it. It looks like it's an irrational number because it goes on forever. Okay, let's cube root. So to cube root, you press math, and then you go to your cube root option, 54, and this equals 3.78. The cube root of -1, we can do that because it's an odd index. So math for -1, and we should know that gives us -1. Okay, so this equals -1. Why does that happen? Because we should know -1 cubed equals -1. Okay, because this is simply -1 times -1 times -1. -1 times -1, well, that gives me +1. So these guys become +1, and then this will be -1. So that's why -1 cubed is negative. The fourth root of 29, so I'm going to press 4, math, and choose this value, and it'll be 29. So this will equal 2.32, and then the root of 16, hopefully we know that that's a perfect square, that's 4. We don't even need our calculator for that. So to order this on a number line, well, my smallest value is this -1. So the cube of -1 will go here, and I'll put the estimated value on the bottom. Okay, what's the second largest? The second largest would be 2.32. And I'm going to place on top here the fourth root of 29. Okay. My next value, biggest value, would be 3.78. And that is cube of 54. My next number would be 4, and that is the root of 16. And then my largest value would be 4.24. So 4.24 here. And again, the actual value would be root 18. So there I have listed my values in ascending order from least to greatest. Okay, how the heck would we do this without our calculator? So we kind of done this in 4.1, but we definitely need to know how to do this. So we're going to use no calculator. So anytime you're not able to use your calculator, please show how to do this. So first off, I know I'm square rooting. I know I'm cube rooting. So what I'm going to do is I'm going to first list off my perfect squares. So 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49. I would suggest essentially knowing up to 10. Okay, and again, I can represent this in square root fashion. So 1 equals square root 1, 2 equals square root 4, 3 equals square root 9, 4 equals square root 16, 5 equals square root 25, 6 equals square root 36, 7 equals square root 49. So there's my perfect squares. Okay, and I'm going to use this to estimate square root 27 and square root 16. So square root 16, we actually have right here. The square root of 16 is 4. So this thing equals 4. The square root of 27, we're going to have to estimate that. So root of 27 falls between root of 25 and root of 36. So root of 25 and root of 36. So it falls between those things. What does root 25 equal? Well, that equals 5. Root 36, that equals 6. So now we can estimate. 27 is way closer to 25 than it is to 36. So this is going to be closer to 5 than it is to 6. So this is roughly going to equal, I'm going to say roughly about 5.2. Okay, and maybe I'll put 5.25. Okay, so that's my estimate there, 5.25. Recognize it is not a perfect square, so just to kind of reiterate, this means it's irrational. Okay? This is an estimate. If we actually plugged it in our calculator, it would go on and on and on forever. Okay, so there's our estimate so far. Now, in order to do these cube rootings, well, we're going to have to list out my cubes, my first few cubes. So here, 1 cubed equals 1, 2 cubed equals 8, 3 cubed equals 27, 4 cubed equals, I believe, 64. Let's maybe check that. So 4 times 4 times 4, that's what 4 cubed equals. 4 times 4 equals 16. We're going to multiply that by 4 as well. So 4 times 4 is 16, and then times 4. 16 times 4, that will give us, it looks like that gives us 64. Let's see, 16 and 4. So 6 times 4 gives me what? That gives me 24. Add the 2 up here. 1 times 4 is 2 plus 2, or 1 times 4 is 4 plus 2 is 64. So yes, that would be 64. Now I'm going to stop there because, as we can see, we only go up to cube root 30 and cube root 14. So here we can list it in terms of cubes. So this is 1 equals cube of 1, 2 equals cube of 8, 3 equals cube of 27, 4 equals cube of 64. So recognize how this relates to this, right? So now we can estimate the cube of 14. Cube of 14 falls in between cube of 8 and cube of 27. So cube of 8 and cube of 27. So cube of 8 equals 2, the cube of 27 equals 3. 8 is pretty close to 14, that's only 6 units away, whereas 14 is, let's see here, that's actually 13 units away. So 6 compared to 13, so this 14 is closer to 8 than it is to 27, so I'm going to estimate this roughly to be about 2.35, okay? It's kind of close to the middle, but not quite. So I'm going to say this is roughly 2.35. Now let's estimate the cube of 30. So the cube of 30, let's see here. Well, that's going to fall between the cube of 27 and the cube of 64. Okay. Now the cube of 27 equals 3. The cube of 64 equals 4. Okay, the cube of 30, now 30 is way closer to 27 than it is to 64, so this is going to be really quite close to 3, so it'll be roughly 3.15. Okay, so I'm going to estimate this to be roughly 3.15. And now finally, we are on to estimating our fourth root of 30, sorry. Okay, so again, we have to list our perfect fourths. So it'll be 1 to the power 4, which is 1, 2 to the power 4, that will give me 16, and then 3 to the power 4, kind of have to think about that one. So 3 times 3 times 3 times 3. 3 times 3 is 9, so this is going to give me 9, which makes this giving me 9, and these are still multiplying each other. 9 times 9 is 81, so 3 to the power 4 equals 81. Okay, we can represent this using fourth roots. So the fourth root of 1 is 1, the fourth root of 16 is 2, and the fourth root of 81 is 3 to the power 4. So now we can see and estimate this, that this falls between the fourth root of 81 and the fourth root of 16. Now, 30 is much closer to 16 than it is to 81. Much, much closer. So the fourth root of 16 is 2. So this is 2. The fourth root of 81 is 3. So since 30 is much closer to 16 and it's well below the middle line between 16 and 81, I'm going to estimate this to be roughly 2.10. Okay, so now let us list it in order. Let's maybe use this color here. So first, let's find our smallest number. Our smallest number we guessed to be 2.10, and that is related to 4th root of 30. Our next smallest number would be 2.35, and that would be the cube of 14. Then we would jump to 3.15, which would be the cube root of 30, sorry. Then we'll jump to root 16, which of course is perfectly 4, and then 5.25, which is square root 27. So there we have listed from descending to ascending. Let's see how close we were. I'm kind of interested to see how close we were with these two, okay? And as long as they're in the proper order, that's sort of what we're looking for, but let's see how close we were. So the 4th root of, oh, I pressed the wrong one. So 4 math, and then we're gonna press this guy here. And we're gonna 4th root 30. So that gives us 2.34. So I didn't estimate that super well. So let's see how close I was here. So math 3, math cube root 14. Okay, so I was still pretty close. I was still in proper order. I obviously didn't get it super close. 4th rooting is a little harder, but recognize that we still ordered it properly. 2.4 was much closer to 2.35. I kind of squeaked that one here. So it's good to always check just to see how you're doing, but recognize I still got this being a smaller number than this number, which is pretty darn good. Okay, so there is example 3. Okay, so you can take a quick picture. If you need to copy some things down, rewatch the video, go for it. Let's do one more. It's example 4. And here we have a cube has a volume of 345 meters cubed. Is the side length of this cube an irrational or an irrational number? Explain your reasoning. So remember what a cube is. A cube is a 3-dimensional shape made up of squares having all the same side lengths. So a volume will equal x times x times x. So essentially volume equals x cubed. Okay. Now recognize that we can solve for x here by cube rooting both sides. Okay, so if I take the cube root of both sides, I can represent my side length as the cube of x. So let's figure this out. I can try and solve for x by plugging in my volume, 345. So recognize volume equals 345 meters cubed. I can plug that into my equation and solve for the side length, where x equals side length. Okay, and remember, they're all the same side lengths because it's a cube. So what I'm going to do is I'm going to do cube 345, and that equals x. Okay, so I have to figure out, is this a perfect cube? If it is a perfect cube, then it's rational. If it's not, then it's irrational. So I'm going to go back and use some chapter 3. Okay, I'm going to prime factorize this thing. So let's divide this by 5. So 345 dividing 5, that gives me 69. 69 divided by 3 gives me 23. So you recognize if this thing was a perfect cube, okay, we've prime factorized this. 23 is no longer divisible by anything, by the way. So we can't group this into 3s for numbers. Remember, all the way back, hopefully you watch this video, but to check if something's a perfect cube, you prime factorize and then you group the same numbers into groups of 3 based on your index. Here we were able to nicely, and we could represent it 2 times 3. Down here though, we're running into some issues. We only have 1 5, we only have 3 1 3, and we only have 1 23. So this thing is 345 is not a perfect cube, meaning that the cube root of 345 is irrational. Okay, and that makes x irrational. Okay, we can use our calculator to quickly see just to make sure it is rational. So remember, math, you're going to press 4 and we're going to get that cube root. So the cube root of 345. And if you look at that, x technically equals 7.013579083, on and on and on and on. So this is an irrational number. So there's a bunch of different ways. If you were to ask without a calculator, how could you prove this? You would have to show this. If it technically doesn't say you don't need a calculator, you can use a calculator, you could always just plug it in and show that there is no terminating or repeating decimal, therefore it's an irrational number. Okay, so I hope this all makes sense. Make sure you go practice, go check your understanding with 4.2 and see how you do. If you have any questions, please come ask lots of questions. Other than that, this is a pretty important unit to understand. I know I say that every single time, so I guess every single unit is important. So make sure you do your practice problems, check out AFL 4.2, and let me know if you have any questions.